So today our topic is going to be how to evaluate a deductive argument. And this will involve learning what the concept of deductive validity entails. As you probably already know, deduction centers around the concept of necessity. When does a conclusion necessarily follow from a given set of premises? So during this slide presentation, I'm going to teach you a variety of techniques for how to determine that. One thing you're going to note is that dealing with deductive arguments is slightly more technical and less intuitive than dealing with inductive arguments, but it's nothing you can't handle, and we will take it step by step. So here we go. Since we've been working with induction for a while, let's go back and review the nature of a deductive argument before we get into the question of evaluating and validity. In a deductive argument, you have a claim being made that starting from a certain set of premises that are given, the conclusion necessarily follows. In other words, the claim of the argument is that if you accept the premises, you must accept the conclusion. The conclusion has to be the case. Now, that claim could be correct, that in fact you do have to accept the conclusion if you accept the premises, and in that case, you're going to have what we call a valid argument. Now, the claim could be false. Even if we do accept the premises, we don't have to accept the conclusion, in which case we're going to have an invalid argument. So our first task is going to be to figure out how do we learn when an argument is valid and when an argument is invalid. So here we go on that. When we were talking about inductive arguments, we started to move away from talking about them in terms of being good or bad. That is an intuitive starting point for teaching a distinction of how to evaluate arguments, but ultimately the terms good and bad are not really very helpful and not very sophisticated for evaluating arguments. As we saw with inductive arguments, we can treat a weak inductive argument as a bad argument and reject it. A strong inductive argument isn't necessarily good. It just means that the premises support the conclusion. It doesn't mean the conclusion is true. It just means that if we start from those premises, it's probably the case. It's probably true. And then we will have to go to a second level of evaluation, which we will work on next week. There is an exactly parallel case with deductive arguments. We can reject an invalid deductive argument as a bad argument. So those are bad deductive arguments. However, if a deductive argument is valid, that doesn't mean it's necessarily good. It might ultimately fail. Valid means it has passed the first stage of evaluation and is worthy of further consideration. And we'll worry about that again next week. So a valid deductive argument is provisionally acceptable. It's past the first stage. It's ready to go to stage 2. We might ultimately have to reject it, but it has at least met the first criteria of evaluation. So how do we determine that will be the subject of the rest of this PowerPoint. The concept of validity is really quite simple. It's so simple that sometimes people have difficulty grasping it, but it's really just the idea of preserving the truth. A valid argument is truth preserving. And what does that mean? Well, it means that there's something about a valid deductive argument such that if you put in true premises, something about that argument preserves that truth value down to the conclusion. And ultimately what we're going to see is this is a property of the structure or the logical form of the argument. So valid arguments do that. They guarantee that if you plug in true premises, that truth is preserved down to the conclusion, whereas invalid arguments do not do that. In an invalid argument, you might put in true premises, but you're not guaranteed to get a true conclusion. You might get a true conclusion, but not every single time. You could end up with a false result, and therefore an invalid argument is unreliable. Valid arguments are reliable. You are guaranteed to get a true conclusion if you have true premises. That's the key idea of truth preservation. So in this slide, I'm going to talk about the definition of validity and contrast it with an invalid argument or invalidity. And hopefully by the end of this slide, you'll have a pretty good sense of what we're looking for when we're evaluating a deductive argument. The property of being valid, or validity, is equivalent to being what we call truth-preserving. That is, there's a property that some deductive arguments have that makes them truth-preserving. And what that means is, as the definition here states, if the premises of the argument were true, then it would be impossible for the conclusion to be false. That's what truth preservation means. It means that if the premises were true in a given deductive argument, and based on that assumption, the conclusion could not be false, that means that that argument preserves the truth in the premises down to the conclusion and guarantees the conclusion is true. In contrast, an invalid argument is not truth-preserving, which means if the premises of the argument were true, then it would be possible in some cases for the conclusion to be false. So in an invalid or not truth-preserving argument, the argument form is such that it doesn't guarantee a true conclusion, even if the premises were true. Now, I want to be very, very clear here so you do not misunderstand what I'm saying. I am not saying that a valid argument must have true premises. That is not what I'm saying. The test of validity only asks us to consider what would happen if the premises were true. Sometimes they will be true, but they don't have to be. You can have a valid deductive argument comprised of all false statements, for example, because we're not testing the truth or falsity of the statements in the argument. We are testing the whole argument. And the question we're asking is, if we start with those premises as given and assume that they're true, where would that lead us? Would that necessarily lead us to the conclusion? If so, that's a valid argument, regardless of whether or not the statements in the argument are true or false or whatever combination you might have. There is one case where you can have an argument with actually true premises, but the conclusion is false. And in that case, the truth of the statements would matter because by definition, that would be an example of an invalid argument. And we'll go into more detail about this as we cover the various ways of testing validity in a little bit. But that's the only case in which the actual truth or falsity of the statements in the argument actually matters. For the most part, we're going to approach arguments in a kind of a hypothetical frame of mind. If those premises were true, regardless of whether or not they actually are, what would happen? And I think the next slide will give you an example where you'll understand a little bit more clearly what I'm trying to convey here. So let's look at this argument as an example of what I was talking about in the previous slide. The argument goes as follows. Since Moby Dick was written by Shakespeare, and Moby Dick is a science fiction novel, it follows that Shakespeare wrote a science fiction novel. Okay, so we have an argument here with two premises and a conclusion. You probably have noticed that this argument consists of all false statements. Moby Dick was not written by Shakespeare. Of course, you know who wrote Moby Dick. It's the greatest novel in American history, so we don't have to go into that, but it certainly was not written by Shakespeare. And Moby Dick is not a science fiction novel, so the premises are both actually false statements, and the conclusion is false. Obviously, Shakespeare did not write any science fiction novels. Okay, so far so good. So here we have an argument, but all the statements are false. Now, most people who are not trained in critical thinking would look at this and say, well, that's a bad argument. Of course, it's got all false statements. And they would be wrong. This is a perfectly valid argument. Why is it valid? Because remember the definition of validity. It does not require that the premises be true. It just requires that if the premises were true, that we would have to accept the conclusion as true. Now keeping that definition in mind, let's go back to this argument and see if this argument does or does not fulfill that standard. If in fact Moby Dick were written by Shakespeare, hypothetically, and if Moby Dick were a science fiction novel, if those claims were true, even though they're actually false, if they were true, would it have to be true that Shakespeare wrote a science fiction novel? And the answer is yes, it would have to be the case. Why? Because that's what the premises say. The premises say Moby Dick was written by Shakespeare and it's a science fiction novel. If those claims were true, it would have to be the case that Shakespeare wrote a science fiction novel. So, we have here an example of a valid argument. The premises are not true, the conclusion is not true, but that doesn't matter. What matters is if the premises were true, we would have to accept that conclusion as true. The premises make the conclusion necessary, therefore this is a valid argument. The trick in grasping the concept of validity is to rid yourself of your obsession with truth and falsity. These properties of statements are misleading when applied to arguments. We don't look at arguments and say, oh, that argument is true or false, and we don't really care whether the statements in the argument are true or false. What we care about when we're looking at an argument is the question, do the premises support the conclusion or not? Do they make it necessary if it's a deductive argument? Do they make it probable if it's an inductive argument? Down the road, when we talk about the ideas of soundness and cogency, the actual truth and falsity of the statements in the argument will come to be important. But right now, for the purposes of learning what makes a given deductive argument valid, don't worry about whether the premises are true, just pretend they are and see where that assumption leads you. So for the rest of this PowerPoint, we're going to learn 3 different techniques for determining whether a given deductive argument is valid or invalid. And we need different techniques because deductive arguments come in different forms and have different structures, and so some are more susceptible to being tested more easily by one method rather than another. These are not particularly complicated, although the idea of logical form may be new to you and may take a little time to absorb. Nevertheless, it's really pretty simple, and with a little bit of practice, you should master it fairly easily. The first test of validity is the easiest to apply, and it really is just a direct application of the definitions we have already learned. The problem with this method is it only works in a very limited number of cases. Nevertheless, if you can successfully apply it, it shows that you truly do understand what you're looking for in a deductive argument. So here we go. The first test is a direct proof that an argument is invalid. You can't really use this to prove the argument is valid, but you can certainly use it to eliminate certain arguments as automatically being invalid. And here's the criterion. The argument will automatically be invalid if the argument has actually true premises and an actually false conclusion. In other words, if all of the statements in the premises are actually true claims and the conclusion is actually false, then of course that argument has failed to preserve the truth. You had true premises, but you ended up with a false conclusion. Now in this case, the test is not hypothetical. We're not worrying about if the premises were true because we don't have to. They actually are true. And we don't have to worry about the conclusion being false because it's actually false. So therefore, on the face of it, such a deductive argument is not truth-preserving and is therefore invalid. This only works in the case where you have exactly true premises and an exactly false conclusion. So as I said, that's not going to happen too often, but it is useful as a first initial step for grasping the idea of validity. So for example, today, the day I'm recording this lecture, is Tuesday. So let's look at an example of an invalid argument starting from that claim. The premise is today is Tuesday, which is actually true since it really is Tuesday. Therefore, tomorrow is Friday. Well, that's actually false because, in fact, tomorrow is Wednesday. So the argument, since today is Tuesday, therefore tomorrow is Friday, is automatically invalid. The premise is true, it is Tuesday, but it is false that tomorrow is Friday, and therefore that argument is not truth preserving, true premise, false conclusion, so it's invalid. Here's an example where you can apply the first test of determining that an argument is invalid in this particular case. The argument goes as follows. If George Washington was beheaded, then George Washington died. George Washington died, therefore George Washington was beheaded. Okay, in this case, both premises are actually true statements. It's actually true that if George was beheaded, then he's dead. There are no living beheaded people. So that's a fact. If George Washington was beheaded, then he died. True. And it's true that George Washington died. In fact, he died in 1799. So both of the premises are true. Therefore, George Washington was beheaded. Is that true? No, George Washington was not beheaded. He died of a sore throat, I think, or something that people used to die of back in 1799. So the premises are true, but the conclusion is actually false. So the premises are actually true statements. The conclusion is actually a false statement. Therefore, this argument must be invalid. It did not preserve the truth actually in the premises down to the conclusion because the premises are true, but the conclusion is false. So this is an example where knowing whether or not the statements in the argument are true or false can be relevant to determining if it's valid or invalid. But as I mentioned in the previous slide, this is a very small number of cases where you can actually apply this idea. In most cases, we're not going to be worrying about whether the premises are actually true. We will simply pretend that they're true and see where that leads us. Okay? And you can do that with this example too. You may not know who George Washington is, for example, and that really doesn't matter because you can simply assume that if he's beheaded, then he died, and assume that he's dead. Is it necessarily the case that he was beheaded? No. Had he been beheaded, he would be dead, but he could die from a number of different reasons, so the conclusion isn't necessary whether or not you know who George Washington is. It's just that if you do know the facts, it makes it a little bit simpler to determine that this particular kind of argument is one that is invalid. The utility of that first test of validity is somewhat limited because it only works in a very narrow situation where you in fact have true premises and a false conclusion, which will occasionally happen. Oftentimes, however, you're going to have to deal with deductive arguments that have a different mix. Sometimes you'll have all false claims in an argument. All the premises are false and the conclusion is false. Or the premises are false and the conclusion is true. Or all the statements are true. You're going to have all different truth values kind of mixed up together. So we need a broader test, and that leads us to the second test of validity. Now, in this second test, we don't worry about the actual truth and falsity of the premises. We just pretend that the premises are true, even if they're actually false or if we actually don't know. And that's why this test is so useful. You don't really have to have an enormous body of factual knowledge to evaluate a deductive argument. You don't even have to know if the premises are true. You just have to pretend they are. Assume hypothetically that the premises were true, and then ask, okay, if I did make that assumption, would it be possible for the conclusion to be false? So you're working with what would happen hypothetically if the premises were true. And then the way you answer that question, is it possible for the conclusion to be false, determines whether the argument is valid or not. If your answer is no, meaning it would not be possible for the conclusion to be false if the premises were true, then you've got a valid argument. That argument would preserve the truth. Whereas if your answer is yes, it is possible for the conclusion to be false, even if the premises were assumed to be true, then you have an invalid argument. And again, this is just applying our concept of truth preservation. Does the argument preserve the truth or not if we make the assumption that the premises are true? So we're just applying over, again, the same basic concept, but here we can apply this test to a much broader spectrum of arguments, and rather than simply stick with what we were restrained and confined to with the first test. So here's an example, and we'll do many, many more in class, just to give you the idea. So the premise is Christmas always falls on Thursday. Now that is in fact a false statement, because Christmas falls on every different day of the week depending on the year. But if Christmas did hypothetically always fall on a Thursday, would it necessarily be the case, therefore, that the day after Christmas would be Friday? Could that be false? Could it be false that the day after Christmas is Friday if it were the case that Christmas always falls on a Thursday? So the answer to that should obviously be no. It would not be possible for that conclusion to be false if we assumed it's true that Christmas is always on a Thursday. So assuming the truth of the premise, even though it's actually false, entails the conclusion necessarily. So that's a truth-preserving argument. It is valid. It's passed the first test of evaluation. So that doesn't mean it's necessarily a good argument. It doesn't necessarily mean that the conclusion is true. When we get to the second test, we will see that ultimately we will have to exclude this argument as acceptable. However, it's passed the first hurdle. That premise, given that Christmas Day is always on a Thursday, necessarily leads to the conclusion that the day after Christmas is a Friday. Here's another example of how we use the hypothetical method to determine whether an argument is valid or not. Since the Department of Defense building in Washington, D.C. has the shape of a hexagon, it follows that it has 6 sides. Here we have an argument that is analogous to the previous argument I talked about Moby Dick being a science fiction novel. It is an argument where all the statements are false. The Department of Defense building in Washington, D.C. is called the Pentagon. It is a pentagon, and it has 5 sides. So the premise here is false, and the conclusion is actually false. But we need to put that aside to determine whether or not this argument is valid or not. If it were the case that the Department of Defense building was a hexagon shape, if that were the case, then it would have to be the case that it has 6 sides, because a hexagon, by definition, has 6 sides. So if the premise were true, the conclusion would have to be true. And therefore, this is a truth-preserving argument, and it is valid. All right, so if you're still with me, you probably now have realized that validity is a simple concept. It's one idea. It just takes a little bit of time to grasp, and it's basically just the idea of truth preservation. So now let's turn to the third way of testing for validity, which will ultimately be the most simple, though it takes a bit of practice to learn it. And this third way of testing for validity focuses on that property that valid arguments have, which distinguishes them from invalid arguments. Now, valid arguments we know are truth-preserving, and invalid ones are not truth-preserving. What is it about some deductive arguments that makes them truth-preserving or not? And the answer to that is that truth preservation or validity is a reflection of the argument's logical form or structure, not its content. In other words, what makes an argument valid or not is not dependent on what the argument is about. In fact, the easiest way to test for validity ultimately, as we will soon learn, involves getting rid of all the content and just getting down to the bare logical structure of the argument, which I'll talk about in just a second. So that's the thing to keep in mind in this third test, is that what we're ultimately looking for is what's the form or the logical structure of the argument. So really what it's about simply doesn't matter. Transitioning to the third test of validity will involve things getting a little bit more technical. and so a little bit more formal and might pose a challenge initially to learn, but believe me, with a little bit of application, you'll be glad you took the effort to learn this because it makes evaluating many, many deductive arguments a whole lot simpler. So as we were talking about earlier, the key in truth preservation is the argument's form. I want to talk just a little bit more about what that concept means and then give you an example and then show you how we use it in our third test of validity. So the form of an argument is the logical structure that remains when we get rid of all the content. So what we do is we take the content, like say for example the statement, all dogs are mammals, and we get rid of all of that and we just replace it with a letter, D, that stands for that idea or that statement. And we retain only the terms that connect logically the elements of the ideas in the argument. So if it's an if-then argument, let's say a hypothetical syllogism like if all dogs are mammals, then they have fur, we get rid of the content and we just make that if D, then F. So that's the logical structure of that statement. We've gotten rid of all the content. And this becomes important because what we want to get to is the argument's form, since, as we will soon learn, some forms are automatically valid, no matter what the content. Some forms are automatically invalid, and therefore recognizing the form is by far the simplest and most accurate way of evaluating a deductive argument. So here's an example of what I'm talking about. We have an argument. If you work hard, then you will succeed. You work hard, therefore you will succeed. So this is a hypothetical syllogism. It's two premises that lead to a conclusion. Now, for sake of illustration, if you look to the right, what I've done is I've taken out the logical form or structure of this argument. And that involves using the basic framework, the if-then framework, but getting rid of all the terms that refer to actual things in the world. So instead of saying, if you work hard, then you will succeed, we just have if W, then S. These letters are called variables, and they stand for basically anything. And you could use any letters you like. The only restriction is if you use a letter for a concept, like W for working hard, then you have to use W for working hard and not use W for anything else. Otherwise, you'll get confused. So the logical form of the original argument, therefore, is if W, then S, W, therefore S. Now this is significant, and it's important to learn to recognize the logical form of arguments such as this, because merely by surveying the logical form of this argument, you know automatically, or you will know automatically, that it is a valid argument. It is a modus ponens argument, as we will learn. This logical form has a name, and it has a name because it's guaranteed to work. You will never have a modus ponens argument with true premises and a false conclusion. So this logical form guarantees the truth if the premises of the argument are true. So the concept of logical form will be the basis of our third test of validity. And what we're going to learn to do is recognize those forms which are always valid, regardless of content, and distinguish them from those that are always invalid, regardless of content. At first, this will seem a little bit technical, and it will require a bit of practice, but it will truly be worthwhile because it makes your life a lot simpler, as you'll see. Here's a deductive argument. Let's see if it's valid. If Lady Gaga were an octopus, then she would have 8 legs. Lady Gaga is an octopus, therefore she has 8 legs. Now, initially, many people would look at this argument and conclude it's a bad argument. And if asked why, they'd probably say, well, it's kind of dumb because it's false that Lady Gaga is an octopus. And that would tell us that that person does not know how to evaluate an argument. The question is not, is the premise false, but rather, would the premises make the conclusion true? In other words, is this a truth-preserving argument? Now, we could use our second test of validity on this argument and simply pretend hypothetically that the premises are true, even though that second statement, that Lady Gaga is an octopus, is in fact false, and it would turn out that we could determine that this is a valid argument. If it were true that if Lady Gaga were an octopus, then she would have 8 legs, which it is true, so that's pretty easy. And if it were true that Lady Gaga was an octopus, it would have to be the case that she has 8 legs because octopi have 8 legs. So this argument would pass our second test of validity. However, there's a much easier way to determine that it's valid, and it is by learning to recognize the logical form or structure, which I'll get to in the next slide. So the previous argument has the following form if we get rid of the content. If P, then Q, Q, therefore P. And what we've done is we've gotten rid of the argument being about Lady Gaga or being an octopus, and we've just gotten down to the logical structure of the argument. Now what is significant is this exact form, if P, then Q, P, therefore Q, is a valid form. Any deductive argument that has this form will automatically be valid. This argument form is so important, and the following arguments that we're going to be looking at are so important, that they've acquired names. This form is called modus ponens, and the important thing to keep in mind is that any deductive argument that has the form of modus ponens will automatically be valid regardless of what it's about. So if you go back and look at the Lady Gaga example in the previous slide, you'll see that it has this form. So rather than having to think it through, hypothetically, if the premises were true, would the conclusion have to be the case? It's really much simpler to simply recognize its modus ponens, automatically valid, and then you can move on to the second test, which we'll learn for next week. So learning these forms may take a little bit of time and practice, but again, it's going to be worth your time. So the preceding argument about Lady Gaga, when we get rid of all the content, has this structure. If P, then Q, P, therefore Q. Try to think it through. P stands for Lady Gaga being an octopus, and Q is having 8 legs. So if P, then Q, if Lady Gaga were an octopus, then she would have 8 legs. Lady Gaga is an octopus, that's P, therefore Q, therefore she has 8 legs. So this is the structure. We've gotten rid of all the content. Why did we want to do this? Well, because we now can learn that this particular structure is significant because it is a truth-preserving form. It's called modus ponens. Any argument that has this form will be a modus ponens argument. And the important point about learning this is that any argument that is deductive that has this form, regardless of what it's about, will also be a deductively valid argument. Now we could, and we did, go through the Lady Gaga argument using our hypothetical test, which we have learned and which is quite useful. If the premises were true, would the conclusion necessarily be the case? And we pretend the premises are true and we think the argument through, and it does work and it does show us that it's valid. However, isn't it a lot simpler to simply look at the argument, recognize it's a modus ponens argument, and then conclude automatically it's valid? It's so much simpler. And then we can move on to our second test that we'll learn about next week. So therefore, learning these forms will take a little bit of time, but again, you're going to be glad you did. Here's another example. If you study, then you'll pass. You didn't pass, therefore you didn't study. Is this argument valid or not? Well, we could think it through, assume that it is true that if you study, then you'll pass, and assume that it's true you didn't pass. It would necessarily follow that you didn't study, because the first premise tells us if you did study, you would have passed, which didn't turn out to be the case. So you could think this through and get the right result that it's valid. However, there is a simpler way to do this, and that's simply to recognize the argument's form, which I will show you on the next slide. So the form of that previous argument is called modus tollens, and it is also a valid argument form. Any argument having this form of modus tollens will be valid. If P, then Q, same first premise structure as with modus ponens, but the difference is the structure or the form of the second premise, not Q. Here we have a negation, not, which is a different relationship than we had with modus ponens, which says Q. So let's go back. If P, then Q, not Q, therefore not P. Again, we have a negation also in the conclusion, not P. Again, just like modus ponens, Every modus tollens argument is automatically valid. You simply have to recognize it. Doesn't matter what the argument is about. So if you learn to recognize modus tollens, it's a truth-preserving or a valid form, and you're done with that aspect of evaluation. Here's another example of a deductive argument. Either you are a reptile or you are a fish. You are not a reptile, therefore you are a fish. Now, this argument is different than the others because it's not a hypothetical syllogism, it's a disjunctive syllogism, and it is a valid argument, not because of what it's about, but rather it's valid because it has a certain logical form, and that logical form is known as the disjunctive syllogism. Let's look at it in the next slide. Here's the structure of a disjunctive syllogism. You're presented with an alternative, either X or Y. Now the second premise eliminates one of these possibilities, and if you think about it, that means only one possibility remains. So if I say you're either having X or Y and not X, it follows necessarily you're going to have Y, whatever X and Y happen to stand for. So the previous argument had this structure, and therefore that's what makes that argument valid. Disjunctive syllogism is a valid argument form. Now the thing that we have to keep in mind here is that it is crucial for a successful disjunctive syllogism that the second premise eliminates one of the alternatives. If this is not the case, you might have a disjunction, an X or Y statement, in an argument, but it may not be valid. Only if the argument has this exact form and one of the options is eliminated in the second premise will it be a valid argument form. Here's our final example of a valid form. If you go to Disneyland, then you'll spend a lot of money. If you spend a lot of money, then you'll have a good time. So if you go to Disneyland, then you'll have a good time. This argument has a distinctive form. It's a hypothetical syllogism because it has if-then in every single premise, and the name of this argument form is a pure hypothetical syllogism because every statement in the argument is a conditional or an if-then statement. Now you might be able to just put the ideas together and see the relationship that the truth of the premises would make the conclusion necessary, but there is a simpler way to recognize that this is a valid argument, and it has to do with examining the form. So the previous argument is a valid argument, not because of what it's about, not because of its content, but because of its form. It has this form. If P then Q, if Q then R, so if P then R. Any argument having this form will be a valid argument. The truth of the premises necessarily makes the conclusion true. So again, what we have to learn to do is to recognize these valid forms because they are shortcuts to getting us the correct answer for determining whether or not an argument is truth-preserving or not. So we've seen how learning to recognize an argument's form can be very helpful for determining if the argument is valid. Some arguments are of a form that is truth-preserving, and recognizing that form allows us to conclude automatically that they are valid. Let's shift gears now and look at some deductive arguments that do not have valid forms. At first, you might have a bit of a challenge to distinguish these invalid forms from the valid forms, but do note that they are different, and we will be reviewing many examples to help reinforce the distinction. Let's take a look at this argument here. If Napoleon was eaten by a lion, then he is dead. Napoleon is dead, therefore he was eaten by a lion. We could in fact use our first test of validity to evaluate this argument, because it is in fact true that if Napoleon was eaten by a lion, then he's dead, and it is also in fact true that Napoleon is dead, and it is in fact false that he was eaten by a lion. So we have an example here of true premises, but an actually false conclusion. So therefore this argument fails by our first test of validity. However, it also fails because this argument has a structure that is not truth-preserving, and the structure will appear in the next slide. And here it is. This invalid argument form is known as affirming the consequent. If P, then Q, Q, therefore P. It's called affirming the consequent because in an if-then statement, the if part is called the antecedent, and the Q part is called the consequent. So this argument in the second premise affirms the consequent. Now you might look at this argument and say, wow, that looks an awful lot like modus ponens, but you'd have to look a little bit more closely to see that that is incorrect, because in a modus ponens argument, the second premise would not be Q, it would be P. It has a completely different structure. Modus ponens is a truth-preserving form, but this form, affirming the consequent, is not. It is possible to have an argument of this form with true premises and a false conclusion, so it is not a truth-preserving form. It doesn't guarantee 100% of the time a true conclusion from true premises. And the previous example about Napoleon demonstrates that. We had an argument of this form with true premises, but the conclusion was false, so it's not a truth-preserving form. Here's another example of an invalid argument. If you study, then you'll pass. You don't study, therefore you won't pass the class. So the idea here is that even if those premises are true, that if you study, that you'll pass the class, and it's true you don't study, it doesn't necessarily follow that you won't pass. You might pass anyway. In other words, that conclusion could be false. So the conditions in the premises might be fulfilled. If you study, then you'll pass, and you don't study, you might still pass if, for example, you cheat, and therefore you pass the class, but you don't do either of the things that are indicated in the premises. So therefore, this argument isn't truth-preserving, and therefore it's invalid, but it's easier to see that it's invalid because it has a certain form that we will learn to recognize. And that form is right here. The previous argument has the form if P then Q, not P, therefore not Q. So think it through. If you study, P, then you'll pass, Q. You don't study, so that's not P, therefore you don't pass, not Q. And as we saw in the previous example, even if those premises were true, the conclusion could be false. So an argument that has this form is not truth-preserving, and it's not a valid form. It's an invalid form. The tricky thing about invalid argument forms is that they may sometimes work. In other words, you might put in ideas and get a true conclusion from true premises, but what makes them invalid is that they don't work every single time, 100% without fail. Valid arguments do work 100% of the time and never fail. So invalid arguments are unreliable. They might work in certain idiosyncratic cases, but you cannot trust them 100% of the time. That's why they are bad deductive arguments. Here's another example, and our final example, of an invalid argument form. Either Los Angeles or San Diego is a city in California. Los Angeles is a city in California, therefore San Diego is not. So here what we're trying to conclude is that something is not the case because one of the alternatives in the first premise is fulfilled. But this is clearly an invalid argument. Both of the premises are true, but the conclusion is clearly false. So what went wrong here? Why isn't this a valid form? It certainly looks like the disjunctive syllogism that we already studied, but in fact it's not. Let's see why. The previous argument is an example of a failed disjunctive syllogism. It has a disjunction, either P or Q. The problem is the second premise does not eliminate one of the possibilities. Since P or Q can both be the case, if we say that P is the case, that does not imply that Q isn't also the case. As we saw in our previous example, it can be true that Los Angeles and California both are cities in California, so either one or the other is, and therefore by saying Los Angeles is, that doesn't imply at all that San Diego is not. And the important thing here is to learn the structure. Because this disjunctive argument does not eliminate one of the possibilities in the second premise, it cannot be a valid argument form. So as I'm sure you've realized many slides ago, dealing with deductive arguments is a tad more complex than dealing with inductive arguments. It's more technical, and it has more of a conceptual apparatus that we need to apply. It's less intuitive than dealing with inductive arguments, but that doesn't mean it's unnecessarily difficult. It's just a matter of learning the forms mostly and recognizing them when they appear, And that really just reinforces the basic idea of validity as truth preservation. So we're going to keep reinforcing that idea. We're going to practice the forms, and what might initially seem kind of mystifying will soon fall into place, and I'm sure you'll be able to recognize these with facility really soon. And so now the only thing left to do is to practice what we've learned. In the module, along with this slideshow presentation, I have included a set of practice exercises for you to work on where you can reinforce and apply some of the ideas you have been learning throughout this presentation. And also you will find a answer key to help you out once you've done those exercises. I very strongly encourage you to do the practice exercises because that's really the only way that you'll learn to recognize many of these forms. And the more you do the exercises, the better off you're going to be. Remember the point I've made since the beginning of this class, critical thinking is a skill. And applying these argument forms to determine whether an argument is valid or not, that's a skill. And the only way we can acquire a skill is through repeated effective practice. So do the exercises, check your results. If you find you get a result that does not accord with what you think is the case, post it and ask a question and post it in the forum or send me an email, either one, and I'll be happy to explain what I think is going on there.